Hello, and welcome to my video lecture on Apache and Samba. My name is Stacy Morganroth-Lapham, and I am the instructor from Schroeder High School. In this video, we're going to explore Samba and Apache, as well as demonstrate how to set them up on a Linux system. This video will include background information on both services, setting up, and securing each, as well as accessing each from a Windows client system. Let's go ahead and start with a simple overview of what Samba is. Samba is an open source software suite that was created by a man named Andrew Trojel. He did some packet captures of traffic between both a Windows system from a file server to another system, and he looked at those packets creating a Unix-style software that looked and acted like a Windows machine. Samba runs on Linux, but it's able to communicate with Windows clients, just like it would for a native application. Samba basically looks and is created to act like a Windows machine or a Windows server in the environment. Samba is able to provide this service by employing what we know as a Common Internet File System, or a CIFS. At the heart of the CIFS is the Server Message Block, or SMB protocol. Samba does this by performing four things. 1. It can do a file and print service. 2. Authentication and authorization. 3. Name resolution. And finally, 4. Service announcement. Before we can get into configuring files, let's make sure that Samba is correctly installed. Using a Linux server, and in this case we're using CentOS 7, we're going to go to the terminal and type in the command yum install samba -client-y. When we do this, we're telling the system to go ahead and install Samba. Not only are we installing Samba, but we're also making sure that we've installed and are running the latest version of Samba. Once we've done this, we can create some users and a directory to share. A user has been created, as you can see on the screen, by the name of test. We can also add as many users as we want. So let's go ahead and add a few more. So using the command once again, user add, we can name any person we want to give permission to be a user in the system. In this case, we've added user named Test, user named Angel, user named Joe, and user named Peyton. They all now have access. We can see that there is in fact 5 users: Angel, Joe, Peyton, Test, and our initial user. Now that we have created 5 new users, what do they have access to? Well, we also need to create some new files or directories for those users to be able to have access to, or to, do whatever they need to do with them. If we use the command mkdir, that simply tells us, or tells Linux, to make a directory. And then you can give your directory any name that you so choose. So here we can see that we created a new directory by the name of Morgasa. If we wanted to, we can create a new file in that directory as well. And we can also see that a new file in the directory Morgasa was created. Using the command cat, we simply tell it that we're going to create a new file, and then we give it a name. And in this case, we gave our file the name project. And since it is a text file, it's a .txt. Now that we've created our files, our directories, and our users, we need to be able to decide what kind of permissions we're going to give for those users when they're accessing our files. There's going to be times where you're not necessarily going to want everyone to be able to change the things that you have in a directory or a file. You might want them to be able just to have read access or write access. Or you might want to say, here, these 3 individuals in this group have access to execute whatever they need to in this file, but these other individuals can only read what's in the file. It's a security measure as well as kind of a checks and balance to make sure that all the hard work that you've put in is not going to necessarily or accidentally be wiped out or changed. So in this example, we're going to just go ahead and say, you know what, the stuff in this file, the stuff in this directory, it's really not that big of a deal. So we're going to give permission to read, write, and execute for all the users to our project folder. We can see that our users Angel, Peyton, Joe, Test, and User have been added. They've been added to a group by the name of Project Group, and they're given full permission to the directory Morganza, as well as the file project within that directory. So in other words, all of our users have full access to read the file, to read into the directory. All of our users have full access to write in the file, and all of our users have full access to execute the file. So far, we've discussed a little bit about Samba's history. We installed Samba on our CentOS Linux server. We created 5 users. We created a file. We created a directory. We set up a group for that directory, and we've granted permission to the users. We've done a little bit of background setup in our CentOS 7 Linux server, and now we need to set up Samba to share with a Windows server. Still using the Linux CentOS 7 terminal, we can use the command yum update Samba. Using this command will make sure that we're running the most up-to-date version of Samba, as well as check for missing data that we will be needed for sharing with our Windows server. Still in our CentOS 7 Linux terminal, we want to use the command cd whack etc whack Samba to make sure that we move into our Samba directory. Once in the directory, we can use the command ll or ls, and we can see that we have 3 items within that directory: our lm hosts, our smb.conf file, and an smb.conf.example file. The smb.conf file is where we're going to find editable information for our Samba configuration. Lastly, we are going to use the IP addresses of both our Linux and our Windows server. We want to do this to make sure that they're communicating to one another. So the way that we're going to do this is that we're actually going to take the IP address of the Windows server and ping it from the Linux server. We're going to do the opposite with the Linux server, and we're going to ping the IP address of the Windows server. If you configured your Windows server and your Linux server correctly through Samba, then both servers will be able to communicate regularly and continuously with one another. Since we've set up Samba and configured it to work with our Windows server, let's talk a little bit about Apache. Apache is an open source software available for free. It runs on roughly 67% of all web servers in the world. It's fast, it's reliable, and it's secure. It can be highly customized to meet the needs of many different environments by using extensions and modules. It delivers content that can be accessed through the internet, including HTML documents, multimedia, such as CSS style sheets, and client-side scripts, such as JavaScript. Linux Apache is the web server that's most frequently used on the internet today. It was originally developed in 1995 and was a core technology responsible for the initial growth of the World Wide Web. Today, it serves over 54% of all websites. It's pretty popular. It's very robust, meaning that it can handle large volumes of traffic on a single server. And it scales really well regardless of the size of the site or the number of requests to that site. Apache Web Server, like Samba, runs on both Linux and Windows servers. Since they run on both, they must be installed on both. So using the CentOS 7 Linux server, you have to install the package called the HTTPD, which means the HTTP daemon. Once you have run that command, you need to find out if your system already has the package installed. And you can use the command rpm-q. If the package is not installed, it must be installed. Once again, using the yum install HTTP. There are other packages that can be installed as well, such as yum install mod Perl, P-E-R-L, and that's installing the Perl module, which is Apache's Perl interpreter. But just starting out, you're really not going to need those extra modules. Just like anything else, if you create it or if you install it, you need to see if it's going to work, if it's going to start up. So once we've installed Apache, we need to start it. We can test to see if Apache is installed on our Linux server correctly by using the command sudo service httpd start. And obviously, if it starts, it's installed correctly. If it doesn't, we need to go back to our yum command and try to install it again. Since Apache has been installed correctly to our Linux CentOS 7 server, we need to switch over to our Windows server. Apache can be installed and configured to host a website from a Windows server. On the Windows machine, you're going to download the latest version of Apache's web server. Following the steps on screen by Apache's installation wizard, you will reach a screen asking you for your domain name, network name, and email address. It's essential that you make sure to fill out each field in the correct format as demonstrated or as required by the installation wizard. So normally, while we're working with an installation wizard, especially for softwares or programs that we're not really familiar with, we generally tend to go with a recommended setting or setup We tend not to kind of go off and do our own custom thing. However, in this case, we're actually going to select the custom setup. Once we do that and we hit the next button, you're going to see a screen that's going to ask you what web server you're working with. You want to go ahead and click on Apache from the radio button list. And then the other thing you want to do is you'll see it has it says install to, and it has a path. You want to make sure that you document the installation file location because you're going to need it later on. More than likely at this point, you're probably going to get an error message after telling you that the Apache could not be configured, and this is where we're going to edit your apache.com file. Don't get frustrated. This is actually a normal part of this process, and we're going to configure the Apache to run and work correctly with our Linux server in the next few steps. Okay, so what we're going to need to do is from our Windows desktop, we need to go ahead and go to our Start button, then find Programs. Within Programs, we're going to find the Apache HTTP server and whatever version number we installed. In this case, we can see that it's Apache HTTP server version 2.2. We're going to go ahead and open up that file. Once we've opened up our Apache HTTP server 2.2 folder, we can see a list of options. In our case, we're actually going to choose the Configure Apache Server option. Okay, so now that we've opened up our Configure Apache Server folder, we're going to choose the Edit the Apache.conf configuration file. What this is, it will take us to an editable notebook text file that's responsible for the configuration of our Apache server. Since this is an editable notepad file, it's important to only change certain and necessary components. In our case, we're going to scroll down the text until we find the section labeled Document Root. The document root in this case is listing our Apache drive and location. Once we've located our document root, we're going to change the document root to point to the location of our website folder. This is where our installation file locations is going to come in handy. Like I told you earlier when we started in with the installation of Apache on our Windows server. Also, it's really important that the slash marks are pointed in the correct direction as demonstrated on the screen. Using that same notepad editable file, we are going to look for our directory. And just as we did for document root, we're going to change our drive location of the directory to match. Once again, don't forget to make sure that your wax or slash marks are going in the correct direction. Now our document root and directory drives and locations should be identically matched. Now we're at our final steps. In order to make sure that we installed Apache correctly and that we configured it correctly to our Windows server, we need to test our configurations. So we're going to go to the Apache icon in your taskbar. Right-click on the icon and stop the service. Once the service has been stopped, we want to go ahead and restart it to make sure that any of the changes to Apache's configuration has been accepted and has been changed. If it won't start or you're given an error, you need to go back and modify your configuration file properly. Some of the problems that can occur generally occur back during the installation process, back at the document root and directory drives or locations. You need to make sure that they match and that they are also the correct drives or locations of the website folder. Once your service starts and there are no more errors, you can then go to any web browser and type your local host IP or type 127.0.0.1 in your address bar. If it comes back with it works, or it comes back with anything other than an error, you're good to go and Apache has been configured and installed.